and welcome, and in this video we're going to be talking about the transformations of quadratic functions. Now, this is going to be a bit of a quick video because we actually already talked about transformations, and that was with the absolute value function. Now, all those transformations affect both graphs the exact same way. Actually, those transformations affect every single function the exact same way. So this is going to be a bit quick. Now, we have our parent function for the quadratic function here, which is y equals x squared, and our transform function. And this will look kind of similar to our absolute value functions. So if we take a look at those, here is our graph of the parent of the absolute value and quadratic families. As you can see, they are kind of similar. They continue up forever in each direction. The domain is all real numbers. They both have a vertex, but that's kind of where they stop looking similar. One is a big V, whereas the other is a big U. However, these transformations affect both functions the exact same way. Now, remember with our absolute value family, remember H shifted the graph left and right, remember? K shifted the graph up and down, and A vertically stretched or compressed the function as well as reflected it over the x-axis. So remember, these were the transformations for the absolute value family. What I want you guys to see is that it's the exact same. So here's our parent function for quadratics. It's the exact same for parabolas, which is a quadratic function. See how it affects both graphs the exact same way. So I'm going to go ahead and get rid of the absolute value for a second. And we can see that these are affecting this function the exact same way. A is vertically stretching and compressing the graph, as well as reflecting it over the x-axis when A is negative. So see, when A is positive, it is opening up. H, remember, is shifting the graph left and right, where K is shifting the graph up and down. Now, I'm going to kind of quickly rewrite what each of these values did to the function. So let's go ahead and take a look at that. So remember, when we added and subtracted inside the absolute value, that moved our graph horizontally to the left or to the right. The same is to be said with quadratic functions. Instead, we're not adding or subtracting inside an absolute value, we're adding and subtracting inside a squared binomial. As we can see here, it's inside that squared binomial. So when we add inside the squared binomial, we're going to be moving to the left that many units, and when we subtract inside the squared binomial, we're going to be moving to the right that many units. And remember, when we added or subtracted outside the absolute value, that moved us up and down. However, in this case, we're adding or subtracting outside the squared binomial. So this is going to shift us vertically. If we add outside the squared binomial, we'll be moving up that many units. And if we subtract outside the squared binomial, we'll be moving down that many units. And remember, the value of A vertically stretched the graph, vertically compressed the graph, or reflected it over the x-axis. Now remember, vertical stretch is when we stretch the graph vertically and it makes the graph appear a lot more narrower, okay? It's a lot skinnier. However, if we vertically compress the graph, so we compress it down, that actually makes it appear a lot wider, okay? And these are dependent upon the value of A. So the first thing I'm going to talk about, though, is when we reflect over the x-axis. Remember, that happened when A was negative, and that's all that that negative means. So if A is negative, we are reflected over the x-axis. And now remember, that's all that the negative means. So if A is, say, 7 or -8 or -5 or 10, that's actually going to be vertically stretched. So we can say if the absolute value of A is larger than 1, then it is vertically stretched by that absolute value of A. Remember, we do not say that it's vertically stretched by -2 if that was the case. It would be reflected over the x-axis as well as vertically stretched by 2. So if the absolute value of A is larger than 1, then it is vertically stretched by the absolute value of A. And that finally takes us to vertically compressed. Now, if A was something like 1/2 or -3/4 or +2/3 or -2/5, that would be vertically compressed. And once again, the negative only tells us it's reflected. We can never have a vertical compression by a factor of like -1/2. The negative would say it's reflected, the 1/2 would be the vertical compression. So that's when we have a vertical compression. So those are all of our transformations. Now let's take a look at a couple of functions and be able to determine what the transformations are without looking at the graph. So let's say we had this quadratic function here. F of x is equal to 2 times the quantity of x plus 3 squared plus 1. Well, we always want to list our transformations in order from left to right, because that's actually how we would apply them to the graph, in order from left to right. So the first thing that I see, and remember, we are comparing it to our parent function, which is y equals x squared. So we're comparing it to y equals x squared, and the first thing I see is there's a difference of 2. There's 2 multiplying out in front. That is the first difference I notice. Well, what that means is that it is being vertically stretched by 2. And that is because 2 is multiplying out in front, and 2 is obviously larger than 1, or the absolute value of 2 is larger than 1. That means it is being vertically stretched. So that is the first transformation that we see. Now the next one that we see is I see plus 3 inside. Remember, if we're adding 3 inside, that means we're actually moving to the left that many units. So this would shift to the left by 3 units. And the last difference I see between the two is I see a plus 1 outside. So remember, if we're adding or subtracting outside, that is affecting the graph vertically. It's shifting it vertically. And if we're adding outside, that actually means we're moving up that many units. So the last transformation would be that it is shifted up 1. And these would be our 3 transformations. Now we could take a look at the graph and see how this would compare. And we can always use the graph to double check our answer, but we should be getting to the point where we can recognize what the transformations are without actually looking at the graph. But let's take a look at the graph for a second. If we take a look, here is just our normal parent function, okay? Now, what we did is we multiplied by 2 out in front. So notice that is vertically stretching. And let me go ahead and change the color real quick so we can kind of see the difference here. I'll make this red. Now, as you can see, the first difference is that 2 is vertically stretching the graph by 2. We see it already look a little bit more narrow. Now, the next thing that happened is that there was plus 3 inside, and notice that has shifted the graph to the left 3. And the last thing that happened is that we are adding 1 outside. So notice how that shifted the graph up 1. So our vertex is now the point -3, 1, and that actually is a nice little piece of information there. Remember, with absolute value functions, the horizontal and vertical shifts told us what the vertex would end up being. The exact same rules apply here with quadratics. We shifted left 3 and up 1, which means our new vertex would be -3, +1. So that is always going to be the case for quadratic functions. Notice the vertical stretch of 2 did not have any effect on the vertex at all. It did affect the rest of the graph, but it did not have any effect on the vertex. Let's take a look at one more. So we have another example here. Now, once again, I'm actually noticing 4 differences between the parent function and our new transform function. And the first one I'm seeing is that there is a negative out in front. Remember, that negative is telling us that it's reflected over the x-axis. So our first transformation would be reflection across the x-axis. Now the next transformation I see is this 1/4 here. Not -1/4, just +1/4. The negative is just a reflection. What this 1/4 here would be doing is actually vertically compressing the graph. It's going to make it appear a lot wider. So this is going to be vertically compressed by 1/4, not -1/4, +1/4. Now, with that out of the way, the next thing I notice is that there's a -5 inside the squared binomial. Remember, when we're subtracting inside the squared binomial, that actually means we're shifting to the right. So we are going to be shifting to the right 5 units. And the last transformation is coming from the -3 outside. Remember, minus or plus outside the squared binomial is shifting us vertically. And if we're subtracting outside the squared binomial, that actually means we're moving down. So we're going to be moving down 3 units. And now just one last little challenge is, what would the vertex be? Well, remember, the horizontal and vertical shifts tell us what the vertex is going to end up being. Now this vertex, or excuse me, this graph was shifted to the right 5 units, so the x-coordinate is now going to be a positive 5, and down 3 units, so the y-coordinate is going to be negative 3. So we should be able to determine what those transformations are going to be, as well as what the vertex should be, without looking at the graph. But let's go ahead and take a look at the graph real quick. Now the first difference was that it was reflected over the x-axis. So we see that negative here, and we now see it opening down. Now the next thing that happened is that it was actually vertically compressed by 1/4. So we can see it appear much wider. If I don't have that negative 1/4, notice how it just appears kind of normal. It's just flipped right now. But when I put that 1/4 in, it makes the graph look a lot wider, because it is. The next thing that happened is that we were shifted to the right 5. That's because of the -5 inside. And as we can see, we now moved over to the right 5. And the last thing is that we were shifted down 3. So these are our transformations. As we can see now, let me go ahead and shift the graph a little bit. We can now see exactly where the vertex is, which is at -5, +5, -3. And we see all those transformations in action. I hope this video was helpful. If there's any questions, make sure that you let me know. Make sure you are studying and practicing your transformations. If you know them for one function, you know them for all. I'm going to keep making these videos just to kind of really hammer it home, because they are so important to know. But if there's any questions, make sure you let me know. And I look forward to seeing you guys in the next video, where we actually apply these transformations to graphing by hand.